Hello everyone, my name is Matthew Wilson, and this is our intro to synchronous counters. A little step away from our asynchronous counters that we've built in the past, but let's go ahead and get straight into it with our five design steps for creating our circuit here, and our first one being our state diagram. So the main goal of today is to create a counter that goes up and down from 2 to 7, and that range goes 2, 3, 5, and 7. As you can see here, every time our inputs are on or going incrementing by 1, it'll start from 2, 3, 5, and 7 and go around in a loop. But if our input's off, it will go ahead and go down or backwards from 7 to 5, 3 to 2, 7, 5, 3, 2. And our tables are quite the same. Your pretty standard layout. We have our present state, next state, and our required flip-flops, and today we went with our JK flip-flops, as you can see here. So this DEC stands for our decimals, so 2357, and then our S is our inputs to switch it from up or down. So when this is on, it's actually reversed or going down, and a pretty simple layout here. Next, we have our K-maps, which are pretty much two steps in ones because I have our Boolean equations as well. And if you guys can see here, we actually have a pattern with K2 and J2, and it's that both of them can be represented by using a exclusive NOR gate, which I will go ahead and show in the circuit now. Okay, so over here in Logisim, we have our circuit, and as you can see here, we have what I was talking about with our J2 and K2 circuit, which is made useful with our exclusive NOR circuit, so it saves us quite a bit of time. And then basically just our standard layout of the circuit here. So if I go ahead and just jump right into it and kind of start off how the circuit works, we're going to have 2, 3, 5, and 7. And we can do this as many times as I want to. It will not change. And if we go ahead and turn this off, 7, 5, 3, 2, 7, 5, 3, 2, as many times as I would like. And on this circuit, I do have a clear switch, although it's not necessarily working because in order to use this clear switch, you would need 0 in our range of values, which we don't have. So you can't really use it to initialize the circuit. But what you can use is this PRE input, which I've created here. I guess which kind of just jumps you to any number you want to put it on. So right here I have it on these two here, which will just set this to 5. And from there I can just kind of start us at 5, so it goes to 7, and then back to 2. So it's kind of a nice easy way to kind of pick and choose where you want to go. And then so in the circuit we go up and down from 2, 3, 5, 7 to 7, 5, 3, 2. But there's a lot of different ways you can go about counting numbers, whether it be counting even numbers or counting odd numbers, prime or not prime numbers, and basically the applications that decide that it all just boils down to your design process and how you design the circuit. So with your starting off with your state diagrams and then your state tables, and your K-maps can help you decide what values you want to be um, sequencing from or going from and to. So basically that's how you change it up. And there's different ways to do it. Like I said, it doesn't just have to be up or down. And that is all I have for you guys today. Thank you.